Good morning. Today we are finishing up this unit 3 with our CO20. I can find the least common multiple of a set of numbers. So a multiple is the product of a number and any non-zero whole number. So multiples of 3 would be 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and so on. So when you're finding those multiples, you go through and you actually multiply it out. The number times 1, the number times 2, the number times 3, times 4, times 5, and you keep on going as far as you need to go. A common multiple is a multiple that is shared by 2 or more numbers. Example, the common multiples of 4 and 6. So you need to find the multiples of 4, then you need to find the multiples of 6 and find which ones they share. Multiples of 4 would be 4, 8, 12, 16, 20, 24, 28, 32, 36. Multiples of 6. 6, 12, 18, 24, 30, 36. So after you're looking at your multiples, find the ones they have in common. They share 12. They share that 24. They share a 36. Those are common multiples. So common multiples are the ones that they share in common. The least common multiple would be of these two numbers, the least common multiple would be which is the smallest multiple that they share in common. So when we're looking at fractions, the least common multiple is also the least common denominator. So if we have 7/10 and 3/4, we want to find that least common multiple to put on the bottom. If we don't have the least common multiple, but we have a bigger multiple, it just means you're going to have to simplify more at the end. So the least common multiple of 7/10 and 3/4, so we look at the 10 and the 4, and that least common multiple would be 20. 40 is a common multiple, 10 times 4. You multiply them together, you get a common multiple. But we would have to divide it down to simplify it at the end. If you start with the least common multiple, you won't have to simplify as much at the end. So using the least common multiple, I kind of jumped ahead a little bit. 2 model trains share a station, but they run on separate tracks. One of the trains returns to the station every 4 minutes. The other returns every 6 minutes. Both trains just left the station. When will the trains next return to the station at the same time? So often we see word problems and we get a little overwhelmed. We go, what are they asking for? Remember, we are working on common multiples. So that's telling us we need to find the common multiple. The least common multiple is the first time they're going to hit that station again at the same time. Nick?
Do you have to write down every single multiple that they have?
Well, that would go on for infinity. Okay. If we're doing if we want to know when they return at the next time they're going to return, it tells us we want the least common multiple. So that first common multiple that they share. So what I would do is I would start with 4, 8, 12, 16, 20. I would go out 5. Because sometimes we're going to know right away, if we know our multiples really well, we're going to know what the least one is. Sometimes if we're not sure, go out at least 5 and see if they share any. If they don't share any with the first 5, go out another 5. But you don't have to keep going on and on and on. Not 6th grade. Multiples of 6. 6, 12, oh, I can stop right there, because I found a common multiple. So what does that tell us? 12 what? So read back. When will the trains next return to the station at the same time? What label should I put? Should I just write 12? Nick?
Like 12 o'clock.
It's not hours. 2 model trains share a station, but they run on separate tracks. One of their train returns to the station every 4 minutes. So when we see multiples of 4, that's minutes. Multiples of 6 is minutes. So it's 12 minutes. See if you can work on example 2 while I answer the phone. Okay. Let's move my page up. Finding the least common multiple. So it's the same thing. The first one was a word problem. Now it's just the numbers. So we're going to do the same thing. We have 7 and 8. What multiples did you put out for 7, Ryan?
For 7, I put 1.
What would be 1 times 7 is 7. 2 times 7 is
2 times 7 is 14. And then 21 for 2. And then 28.
Did you stop there?
No.
You kept going?
And then I did.
Okay, so that's the first 5. Remember I said go out 5 and see if you find a common multiple. So let's check and see with our 8s. Multiples of 8 are 8, 16, 24, 32, 40. Oof.
No.
I don't see any common ones yet, so that means I'm going to go out another 5. So going on with my 7s after 35 is 42, 49, 56, 63, 70. So now I'm going to go on with my 8s. 48, 56, oh, 56. Look at that. Okay. So going in your groups of 5 until you hit that number that is the same. Find that least common multiple. Prime factorization. We learned that the other day. So we're going to look at our 2 numbers and we're going to break them down to their primes. So 84 is 2. 2 goes into 8. 4. 2 goes into 4. 2. So 2 and 42.
Okay.
2 is a prime, so I keep that down. Now I need to break up my 42. 2 can go in there again. 2 goes into 4 twice. 2 goes into 2 once. 2 is a prime. 2 is a prime. 21 can be broken up into 3 and 7. So prime factorization says 2 times 2 times 3 times 7. I'm going to leave it just like that. I'm not going to worry about the exponents. Okay, leave it just like this. And I'm going to show you how we're going to match that up with the 360. 360, I can divide a 2 out. And that would be 180. 2 is a prime. 180, I can divide a 2 out, and it would be 90. 2 is a prime. 2 is a prime. 90 can be 2 and 45.
Yeah, and then it could be
2 is a prime. 2 is a prime. 2 is a prime. 45 can be 5 and 9. 9 can be 3 and 3. So we end up with 2 times 2 times 2 times 5 times 3 times 3. Lots of primes for that one. You keep going all the way down until you get to just prime numbers. Now we're going to look to see which primes do they have in common? Nolan?
Can I use the restroom?
Wait until I'm done with construction. So we have a 2 here and a 2 here. A 2 here and a 2 here. A 3 and a 3. So we have 2 times 3 in common. So now if I multiply them, I can find the least common multiple. 2 times 2 is 4. 4 times 3 is 12. So our least common multiple between 84 well, that's not a common multiple. That's the greatest common factor. So we just found the greatest common factor of using that prime factorization. So that was step 1.
Oh.
Okay. Step 2, circle the common factors. 2, 2, 3, 2, 2, and 3. Okay, so finding those common factors. So it says, then multiply the common factors, 1 for each pair, and all the uncircled. So we have the greatest common factor we found was 12. Now we need to multiply through the uncircled. So we have 12 times our 7 times 2 times 5 times 3. So we found that greatest common factor and took those out. Then we multiplied through the uncommon primes, the ones that they don't share. So we're multiplying our greatest common factor with all the other primes. So 12 times 7 is 84 times 2 gives us 168 times 5 gives us 168 times 5. We're getting into bigger numbers. 5 times 8 is 40. 5 times 6 is 30. Plus 4 is 34. 5 times 1 is 5. Plus 3 is 8. So that gives us 840 times the 3. 3 times 0 is 0. 3 times 4 is 12. 3 times 8 is 24. Plus 1 is 25. Holy smokes, look at that. Least common multiple. Why do you think we wanted to do prime factorization with this one, Brielle? That would have been a ton of numbers if we were going to list them. 360 is a really big number. We don't want to have to list those numbers out. Those aren't numbers that we're used to using. So we have to use a lot of brain power trying to figure out what the multiples of 360 are. What are the multiples of 84? They're not common ones that we multiply out. So use prime factorization for it so it's a little bit easier. So we know how to find that greatest common factor. That was step 1. Step 2 was to multiply the uncircled factors, the uncommon ones. So we took that greatest common factor and we multiplied all the other primes and we got the answer. So let's move the page up. Okay, so it says circle the common factors. Oh no, that's step 2. Example 4, using the least common multiple, find the LCM of 36 and 72. So you can make your sets going out and find what the common multiple is, or you could do that prime factorization. So if we're going to make our list, we would start with 36 and 72 like this. So 36 times 1 is 36. 36 times 2, what's 36 times 2? 2 times 6 is 12. Carry the 1. 2 times 3 is 6, plus 1 is 72. 72 times 1 is 72. Oh my goodness, that was an easy one. So our least common multiple is 72. They gave us an easy one for that. Now we need to find the least common multiple of 24 and 30. 24 times 1 is 24, times 2 is 48, times 3 is 72, right? Yep, 72, times 4, 96, times 5, 120. So now that I went out 5 times, now I'm going to do my 30 going out. So 30, 60, 90, 120. Oh boy, I don't need to go out anymore because I see that 120. If we were to use prime factorization with that, 24 would be 2 and 12. 12 is 2 and 6, 2 and 3. So we have 2 times 2 times 2 times 3. 30 is 2 and 15, 3 and 5. So they share the 2 and 3. 2 times 3 is 6. Multiply our uncircled numbers. So 6 times 2 is 12. 12 times 2 is 24. 24 times 5 gives us our 120. Either way, you get the same answer. The least common multiple. There's only one least common multiple. So with that, I'm going to stop our lesson and say have a good day to the rest of our classmates at home.